The power of infinity. Hello. Welcome back to Math Time with Professor Prime. And I am your host, as always, Professor Prime. I don't know why, but we're gonna roll with it. And you know why we're gonna roll with it? Because it's an awesome video. And you know why it's an awesome video? Because today we're gonna be discussing the power of infinity. And you know what we're gonna do when we talk about that, when we discuss infinity? We're gonna go to infinity and beyond. That's what we're gonna do today. Let's get ready for it. Take it away. Infinity. So, what is infinity? A lot of y'all tuning in, you no doubt already know. But I want to define it, so humor me. Let's talk about it. Let's get into it. Infinity represents the boundless, the endless, the unlimited. And so in this video, I want to focus on like numbers, but also talk about why I am absolutely crazy about infinity and how infinity within itself is fundamentally bonkers. So let's get into it. A lot of times, if we're thinking about infinity, you might think about counting, you know, and I think it's perfect to talk about that because that also indicates that infinity is not itself a number, but a concept, an idea. Um, it represents something like numbers do, but something a bit different. So let's say I'm counting and I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? Then I keep on counting and I work my way up to 100. I work my way up to 1,000. I work my way up to a million, then a billion, then a trillion, then a quadrillion, then a quintillion, and so on and so forth. And I'm just getting larger and larger and larger and larger. And that is the idea with infinity, right? Or part of it. We'll get into that later, though. But the idea is like I keep on going and going and going. So when I go to infinity, I never actually stop. Like I keep on finding different ways to talk about numbers that are getting higher and higher. And so that right there, what we were just talking about, the natural number, the whole numbers, that's just part of it. So that's just one type of infinity. So what it is it's an infinite set. And if we're going to talk about a set real quick, it's a collection of elements. We're going to go with a collection of common elements in this case. And there's much more to say about it. There's classes upon classes you can take on set theory, which is used all over math. But for the purposes of this video, we'll be talking about infinite sets, so collections of numbers in this case. And with the natural numbers, that's one set, right? That's a type of infinity. But you might also have negative versions of those numbers, right? And but you have -1, -2, -3, -4, -5, -6, and so on and so forth. And that's a type of infinity. Um, and so you might have, your positive natural numbers there, but you might have negative versions of that. And that's something to consider. But then you want to look at the big picture, and what those represent is they're subsets of integers, another way to talk about whole numbers. And that within itself is a type of infinity. And then you can look at a set of rational numbers. And a rational number is just a number where it can be like you can put it down as a quotient. So like m over n. So like something like 1 over 2, like 1/2. But all the integers are subsets of that too. And so that's a different type of infinity. And then the numbers that can't be put like that, the set of irrational numbers, so things like square root of 3, where you can't put it in that form. And I guess like to kind of go back real quick with the rational numbers, it's just like it's an integer over an integer. That's the key. um, so yeah, so you have your natural numbers, you have your integers, and with your integers, you can say that hey, the natural numbers are a subset of that. And you can also take just negative integers and say that that's also a subset. And then, like, if you're looking at rational numbers and irrational numbers as a whole, like they form what's known as real numbers. And that is interesting, I think. And each of those things that I just mentioned, they're different types of infinity. Like they're different types. And what's really cool is that you get into this idea that you can actually count infinity. Like you can say that there are larger infinities. That's wild to me. Like, so for instance, right, if the natural numbers are, a type of infinity, right? Like it's an infinite set. It's a type of infinity. And the set of integers, which it is a subset of, is also a set of like sorry, an infinite set. Then is one larger than the other? Yes, in this case. And that's a whole nother thing for another day, but you can define some things as infinite. Blah, 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 blah. You could say that some things are countably infinite and some aren't. And that's, again, like a whole nother story for another day, but notice, if something is countably infinite, it is denumerable, which is a word that doesn't come up nearly enough. But moving on, just everything I said is a type of infinity, and that is wild to me. And while you can look at the numbers that are getting bigger and bigger and bigger, like I said, you can look at things going the other way, and we talked about that a little bit. But what's crazier is like even between numbers, we could do something. So like if I take 0 and I take 1, there's an infinite amount of numbers in between there. That's insane. So it's like even on a smaller scale, it's there. And then if we want to like talk about extending that concept of infinity, so we have like the idea of real numbers, and then we have the idea of different levels to that. So like when you take a graph and you're talking about like the x, y, you know, coordinate system, that whole deal, like you're dealing with another type of infinity there. You're dealing with R2. So it's that extension of R. You can think about it that way. And that's really a subset of an even larger set of like infinite numbers, the complex numbers, the ones that have like imaginary parts. And then, you can go to R3, which is the next step up. And so you're in 3D territory, and that's its own thing. There's infinite things to consider there. Then there are analogs for the complex numbers in higher dimensions, because you could have something like R4, and then you have a complex version of that. And those are quaternions, I believe. It's been a while. And then the same with like R8. And the idea with like R is like you can keep on getting more and more and more there, but it is. I don't know. It's just hard to like talk about without like getting into the nitty gritty. But like just to let you know that there's more layers to this. And then outside of like non-standard analysis, or sorry, outside of standard analysis, there are these things called like the hyperreals. And so there are even more ways to talk about it. Infinity is a crazy, powerful thing. And in the real world, a lot of things that we have aren't infinite, but we can look at things over time, look at what's happening as they're hitting towards infinity. And that's fascinating. That's important. That happens all the time. Um, so yeah, there's a lot, and everything that I said, there's layers to it. There's ways to break that down even further. And then when I look at like infinity and just what it represents overall, it's wild to me because we live in this universe. There's so much of it we don't understand, despite everything that we've learned over time. There's an infinite amount of possibilities, an infinite amount of things to think about. There's worlds inside of worlds inside of worlds. It's wild. And to me, that's very powerful. And one of the other things I wanted to mention real quick is like a lot of times, like in stories, you might see like a structure involving infinity. You might see some sort of story structure that kind of loops upon itself. And that's interesting. Or like certain shapes are associated with infinity, like, a circle or like the sideways eight that you all are used to seeing for infinity, which if I remember to do it, I put at the beginning of this video. Um, so yeah, that infinity symbol is one way, and the idea is like it just keeps on going around and around and around and around and around. And this video is getting kind of long, so I do want to cut it off there. But just to say that infinity is crazy to me because it represents something that isn't limited, and it that is not part of my whole thing, then I don't know what is. So, the power of infinity. It has and will always belong to me. But it's out there in the universe. You should aim to get it. You should aim to explore it. Aim to know more. Or just think about it. It's like it's wild. So yeah. Professor Prime out. See you in the next one. What do I have here? I have tea. And what kind of tea is it? Is it infinity? I don't know why I'm like that, but to answer your question that you totally asked in my head, yes, it is infinity. And you know what? On a side note, I can infinitely drink infinite tea. Cheers. Professor Prime out.